Good morning, beautiful people. Welcome to another edition of Microbiotics BioTalk. I'm your usual host and narrator, Tayo Fasun. This morning, we'll be looking at a topic that I've written about in the past, and the topic is the initiation of infection and causes of diseases. And the first part had to do with the factors that determines infections. The factors that determines infections. I'll be joining you in some few seconds. Stay tuned. So, before any individual can be infected, there are usually points of entry on the human body. And for us humans, most of our sense organs are the point of entries for microorganisms. And these points of entries and these sense organs also double as the initiation point for infections most times. That's why we have the following entry point for most infective microorganisms. We have the mouth, the ear, the nose, the eyes, the skin, and of course our sex organs. Of course, only specific microorganisms can cause infections in these areas, with some of them either staying at the point of infection or spreading to other areas in what we refer to as disseminated infections. And we have many factors that determine if infection can occur in anybody, but three of these are the most prominent, and that's what I'm going to talk about right now. The first one is the specificity of the infectious agent for the target organ or tissue. We have to understand that not all microbes can cause infections in the localized organs that they enter. For instance, organisms like the one that causes typhoid, that's a Salmonella typhi, can only cause disease in the gastrointestinal tracts or the gastroenteric areas, and it cannot cause infections in the genital area. The organism is known to cause gastroenteritis and not STIs. Also, the notorious organism that causes yeast infection in female, that referred to as candidiasis, cannot cause infection in the respiratory tract of human. That's usually the modus operandi. Specific organisms can only cause don't let me use organisms. Specific infectious agents can only cause infections in the area or in the organs that is their target. Except an organism is capable of multi-organ infections, which is prominent in some viruses like Ebola or Lassa, or there is a disseminated infection, like I said the other time, where an infection can spread from the point of entry to other areas. Disseminated infection, which is usually made complicated by our own immune system. Most organisms have their target organs and will not affect other organs. That's the first factor. The second factor has to deal with the load of infectious agents, the load, the size, the number. This actually has to do with the actual number of infectious agents capable of overpowering our immune system either the innate immune system or the adaptive immune system. And let me give a practical example. Now, when we are purifying drinking water, or when we want to determine the purity of a water, we use an organism that we refer to as E. coli, Escherichia coli, as the indicative organism rather. And there's an international standard for the number of the organism that should be found in a particular volume of water for it to be found or considered drinkable. So above this particular number, there is high probability that infection is likely to occur. Let me break it down to the RS minimum. Let's say if 20 or more microbial pieces of an organism is required to cause an infection, and you only get infected by 10, not 20, infection might not start, provided that there are other factors that are not present there. And that third factor is what we are going to discuss next, and that's what we call the competence of the immunity of the person, which we refer to as immunocompetence of the infected individuals. Immunocompetence has to do with the capability of one's immune system to fight infection at any given time. And unfortunately, it varies from day to day, period to period, from human to human. At a point in time, two individuals doesn't have the same level of immunocompetence. So it's a very big factor. A person whose immune system is capable of fighting infection at a specific time, or whose immune system cannot fight infection at a particular time, is called an immunocompromised person. And a lot of factors can make this happen, depending on the site of entry of the individual that is infected, depending on maybe the person is undergoing a treatment regime for other infection at that particular period. It can even depend on the genetic makeup of that individual. So those are the three major factors: the specificity of the infectious agent for the target organ, the load of the infectious agent, and the immunocompetence of the infected individuals. We take a break to continue another time. Before I do that, let me quickly point something out and quickly differentiate between infection and disease, because most people always interchange both, which is not, even though they are not actually the same. Infection is the presence of an organism capable of causing disease in our body system, while a disease is the manifestation of the infection after the infecting organism have overpowered the immune system and the symptoms have started showing. So the truth is that most of the time we are always, and I mean always, infected with one disease causing agent or the other. Why we don't usually have the symptomatic manifestation is because of those three factors that I stated above, among other factors. So this is the end of this microbiotic BioTalk for now. We'll be seeing very much later. Make sure you have a nice day and take care of yourself. Bye.